Yeah, welcome back to this lesson. So in this lesson, we want to look at section 5, which is the second to the last section of AB-100, deploying implementing AI power solutions for enterprise, agentic AI business solution architect. Yes, the name is the former name, and then we are looking at domain 3, which is deploying AI power business solutions for large enterprise. So we have looked at design, planning, designing, and this is deployment, which is the third part, and this is the part that carries the most, like the most in the examination. So what we've been discussing is operate, validate, and govern. And presently we are in ALM, application lifecycle management. So that was what we discussed in the previous slide, and then we'll continue with the remaining on this slide. If you are just joining us, please kindly like and subscribe to our channel. Thank you. All right, so we've looked at ALM for base model, ALM for Office 365 model, ALM for Copilot Studio, for agentic AI system built in Copilot Studio, ALM for Microsoft AI Foundry Agent. Now let's look at Dynamic 365 Finance and Supply Chain Application Lifecycle Management. So you can see that all of these ALMs are slightly different from each other, and you must be able to differentiate them. So these are architecture terms you should understand here. Understand ledger data, okay? So ledger data, the data that can be used. Ledger data are just financial data. They are from financial ledger. Okay, so they are large enterprise financial data that have accounts, customer name, amount, income, so what they spend, export and import, how they spend money. So it is just company financial asset management data. That is ledger data, which is being used in Dynamic 365 Finance and Supply Chain platform. We have purchase orders. So okay. So in purchase order and procurement, we have what we call, in procurement and supply chain, there is purchase order. Purchase order is just an ID that is, assigned to a contractor or to a supplier when they are supplying products. So purchase order, we enable them to trace how the company spend money and what they spend the money on. So for example, if a company is buying a tractor, the tractor will have purchase order. Purchase order will enable the company to track the tractor to a supplier that supply it, and when the contract ID, when the contract was awarded, and then when the payment was made, so you can use purchase order to trace to supplier, to trace to amount that was paid for the item, and so on and so forth. So purchase order is one of the terms used in supply chain and procurement. Then we have prediction accuracy. So how does the agent predict? Is the outcome of the agent prediction accurate when the agent assign purchase order to a particular supplier? Is the purchase order accurate or duplicate? Then we have ERP performance. So ERP is enterprise application, like this Dynamic 365 Finance and Supply Chain application, their ERP system. And then how do you make sure their performance when you integrate with a agentic AI system? The compliance approval. These are financial platform, and security must be very tight. Compliance must be in place. Strong governance must be implemented. So these are the architecture terms that you should understand here under Dynamic 365 Finance and Supply Chain Application Lifecycle Management. So let's look at them in depth. AI assets here include prediction models, anomaly detection, copilot prompts, automation, and knowledge sources. So these are the kind of AI that you can deploy on this platform. So AI that will predict prediction model that will predict suppliers, that will predict supply chain, that will predict cost, and that will help the company maximize profit and minimize cost. Okay, AI can predict maybe if a supplier is charging for a tractor, or if a charge certain amount, maybe $500,000 for a tractor last year, and this year is charging $600,000, then agentic AI can predict whether next year what will it charge, so you know whether to change the supplier or to retain the supplier. or to stop the contract or to maintain the contract. So those are what prediction model can be used for in supply chain and finance. So it can also be used for financial forecasting. Okay, so to optimize profit and minimize cost, to also optimize how the company spend, okay, and where they need to spend, where they need to minimize spend and maximize savings. So it can also be used for anomaly detection. So you can use it to detect you know, a risky supplier. So it can help you to track the supplier behavior over time and tell you whether the supplier is risky and the contract should be stopped. You can also use to detect anomaly in financial system, to detect debt where there is fraud, where there is anomaly in payment, okay, wrong purchase order or fake purchase orders. Then Copilot prompts. So AI asset here is also Copilot prompt. You know, if you are building an agentic AI system, you are also develop prompts. So the agentic AI system to be deployed on this platform can also be built from Copilot if it's not that complex. But if you need a core custom and multi-agent system, you build in Microsoft Foundry. So for prompt management here, you use Copilot prompt, and then here, so if you don't want complete autonomy, you can go for automation. So of course, the purpose is just to automate the process of finance and supply chain processing. And their knowledge sources, of course, you are using RAG database, maybe Dataverse or the ledger data, or SharePoint for compliance data, OneDrive for files, and so on and so forth and so forth. So the environment strategy here under this Dynamics 365 finance and supply chain, development to test to prod. Okay, so and then being a Copilot agent that we are discussing here, we are going to use Power Platform pipeline for this management. So development, test, and production with finance-specific control for ledger data, purchase orders, production orders, and financial information. Very, very important that you set control for all this layer. Okay, everything here is still gated and everything should pass through compliance. Then development to test require data profiling, documented prompts, and quality validation. While test to production require accuracy, safety, ERP performance validation, and compliance approval. And then you monitor prediction accuracy, monitor model drifts and the agentic AI output drifts, monitor throughputs, monitor user satisfaction, and monitor operational impact. So these are what you should understand in Dynamics 365 supply chain, finance and supply chain, agentic AI application lifecycle management. Now we are still on Dynamics 365. Let's look at customer service and CRM, ALM. So let's look at customer service ALM here. ALM for customer experience and service AI in Dynamics 365. And the architecture terms that you should understand here are routing rules. So what are the rules for routing? You know, that agent can use to route action or tasks to a particular tool or to a particular connector. Classification models, how should tasks or actions be classified? Semantic versioning, so when you are using RAG database, how should the semantic indexing or semantic or data should be fashioned, and into context and paragraph and what the agent can understand. How can you manage the entire solution, managing the entire solution on the platform, and CAB approval. So CAB approval, you know, has to do with customer experience approval. So does the customer approve the process? Is their data is secure? So how they interact with the application and agentic AI system secure? And then you should also manage customer emotion using semantic model and the recommendation system here. So very, very important. So you are dealing with customers here. If you are using this for HR, yeah, your employees are your customers and HR, and then you are dealing with them here. If you are using this as a business platform to interact with external customers, for example, then you should know that you design this platform to be grounded in knowledge and not hallucinate, and you know, implement a base model that is grounded in a semantic reasoning and recommendation system. So point number one here, AI assets include copilot prompts, routing rules, classification models, knowledge sources, conversation boosters, and flows. So all these are sources that you can use to, you know, or all these are what you need for developing AI application here. So you need your copilot prompt, you need the routing rules, classification models. So classification model like you can use regression model, or you can use clustering, or any of the base models with semantic reasoning capability, particularly clustering model. So clustering is a classification it's a part of it's an example model that you can use to develop a sentiment analysis if you don't want to go for higher system like a recurrent neural network or LSTM, okay, and so on and so forth. Then you have environment structure. You have development, test, pre-production, and production. So this is the environment structure here. Please take note of this environment structure. Very, very important. And understand that classification model particularly is used here, okay, because of sentiment analysis. So ALM base model, the base model used here should be strong in classification, because you need to classify customer behavior, whether they are angry or they are friendly, based on their mood, using sentiment analysis. So environment structure, development, test, pre-production, and production. Then the life cycle that you should take note here is define use cases, prepare knowledge assets, develop AI logic, package assets, validate, deploy, and monitor. Take note again, define the use cases, prepare the knowledge asset, develop the AI logic or rule, package the asset, validate, deploy, and monitor. Very easy. Then package with solution files. So here you can package agents here, whether they are developed in Copilot Studio with solution files. You can use GitHub repositories. You can use semantic versioning. You can use managed solutions. So managed solutions, there are some agentic AI inbuilt that are already available in Dynamics 365 customer service. So you can use those inside, and if you want to develop your custom agent, you can do that in Copilot Studio or Microsoft Foundry. And then make sure you properly fashion and keep your source file in GitHub repository. So for deployment, you can use Azure DevOps or GitHub Actions if you build a custom model. Okay, so make sure your semantic index or rack database are properly also versioned. Make sure your prompt here is also versioned. Okay, so governance control. So put this governance control in place here, because when you deploy the application to the platform, the data will probably be stored using Dataverse. So data loss prevention must be in place. Sensitivity labels must be in place, because we are dealing with customer data here. You have their name, you have their information, maybe their code, phone number, account number, their personal details. Okay, personally identified information. Make sure they are redacted and kept safe. Okay, make sure you keep apply sensitivity level, so that customer information that you should not expose to the agent are redacted safely from the system. So also implement residency control, very, very important. Some customer data must not exceed border. For example, in Nigeria, if you are building for bank, for example, CBN has said that customer data, every financial information of customer in Nigeria should never exceed border. So such information, if you are deploying and keeping them in UK South, for instance, it is against the standard that is set by the Central Bank of Nigeria. So residency control must be applied using company policy and Azure policy. Then audit log. Okay, you can use Azure Monitor to collect log, and they use log analytic workspace, KQL query to analyze the log, and the metric can be visualized using a metric diagnostic dashboard or Power BI dashboard. Then CAB approval. Very, very important. Approval must be collected from customer before you can use their data to train model, or before you can even store their data in your database. Collect approval from the customers to make sure their information are safe and secure, so that they will also aware of the information that you have and they are using. Okay, very, very important. All right, so security architecture. We are done with application lifecycle management now. Let's move to security architecture. So security is very, very important, and it is not an afterthought. It should be a part, it should be part of the application, part of your design, part of your architecture from beginning when you are designing. So you should not just factor in security after the application has been deployed in use. So implement security design as part of your architecture from beginning. And these are the architecture terms that you should understand here. The first one is manage identities. Okay, so manage identity is on Azure, which allow you to use Azure identity for as an access when you are building application. So if Microsoft Foundry want to access Azure SQL database, for instance, you can use manage identity to access it. So manage identity is used for application interaction within Azure environment. So instead of using customer identity or deploying or OAuth 2 in Microsoft ID, you can easily use Azure provided managed identity, which is very secure and can be used within Azure environment. Okay, so managed identity is one of them. Okay, and it is the easiest, and it is always recommended that you should use it as access layer for application for resource to resource communication. Service principal is also another one. Service principal can be deployed in Microsoft Entra ID and be assigned to application, and the application can use this service principal identity to access every other resource or application you want to access. Then we have Entra ID. So Entra ID is where you can give permission as a developer. You'll be giving Microsoft Foundry developer if you are using Microsoft Foundry, or if you want to administer Foundry agent, you'll be given a Foundry administrator from Microsoft ID. Then if you want to design give agent and authorization or service principal ID is for Microsoft Entra that you implement it. Okay, and then it can also be used for app registration, B2C management and B2B management, and for employee identity management and access management. Everything is built on Microsoft Entra ID. Then we have role-based access control. So role-based access control is just a way of implementing least privilege, which is giving access based on role. So if somebody needs to access an application as a viewer, you give them a viewer role. They need to access an application as a developer, give them a developer role, and the developer should be limited within the environment where they are developing. Okay, so that is role-based access control, and we have least privilege. So that is minimizing access to data, minimizing access to resources and information. Okay, so always implement the principle of least privilege. So give only the privilege that is accessed. Do not give the privilege that is above the requirements of the application or the person accessing. So these are the terms that you should understand under security. They are very, very important and all part of the examination of question. So let's look at the point in depth. AI agents should never have unlimited access. Okay, very, very important. Autonomy does not mean that the agent should not be bounded. We have said several times, autonomy should be bounded. Autonomy must be bounded. So agents must operate within a bounded context. Agents must have boundary. They must have what they can. There must be information that they should never access and never use. Okay, so AI agents should never have unlimited access. Treat each agent like a new employee with defined identity, permissions, data access, actions, and monitoring. So everything should be monitored. So treat agent like graduate training. Okay, that you give identity and permission and what they can do and what they cannot do. So use managed identity, service principles, Microsoft Entra ID, role-based access control, and least privilege. Very, very important for your security implementation. Separate roles such as maker, publisher, security admin, developer, and environment admin from each other. So do not give role that is, make sure you implement role based on specific assignment. So give maker access, give the publisher access, give security admin only security administration rule, give the environment admin only the admin rule, give the developer only the developer rule. So the role should be limited to what they need to perform at the time. Okay, so then the next point is decide whether AI acts AI acts as the user through delegated permission or has itself using its own managed identity. So I will take that again. Decide whether AI acts as the user through delegated permission or as itself using its own managed identity. So is AI acting as the user through delegated permission or acting as itself through managed identity? Because AI should be monitored. If you give access that you are not supposed to give and AI have access to user information, it can act as the user to access information it should not access. So always check whether AI is whether AI is acting as user through a delegated permission or acting as its own self with its own identity through the managed identity that you have given to it. So never add code secrets, very, very important. Never add code secrets and never grant broad contributor access without necessity. Very, very important. Contributors should be limited. Implement the principle of least privilege. All right, so that is security. Now let's move to governance. So data governance is very, very important. So information protection, personally identifiable information must always be redacted. Data loss must be prevented. Residency must be carefully determined using policy and organization policy and Azure policy as well. Data retention must be determined. You can't keep data forever. So determine the period of keeping the data and when the data should be deleted from the database. So these are architecture terms that you should understand here. Microsoft Purview, which is the governance platform for governing information and for PII reduction, residency determination and retention, and data loss prevention. Understand data loss prevention, DLP. Understand sensitivity label, which is always being applied in Purview. So some customer data are sensitive and they are assigned sensitivity label. So they carry that label so that when they are exposed, the agent will always know that this is sensitive. And then we have distal residency, which can be determined using company policy or Azure policy, and the retention rule. So this must be clearly defined. So how long should the data be retained in the system before it is deleted, okay, or recycled? So let's look at the point we have one after the other. So AI should use approved data with classifications such as public, internal, confidential, and highly confidential. So very, very important that you classify data as public data, internal data, confidential, and highly confidential. This can be done in Microsoft Purview. So data loss prevention, DLP, prevents sensitive data movement across unmanaged channels or unsafe destination. So you can apply this to applied it particularly to Microsoft Power Platform data in Dataverse to prevent or manage access or manage or movement of data through unmanaged channel and destination. Then sensitivity label. Sensitivity labels guide what AI can access, what AI can summarize, what AI can store and share. So there are some data it should never access, should never summarize, should never store, or it should never share. So these are sensitivity labels. So you can apply the label based on how sensitive the data is. Then we have data residency. So data residency keeps prompts, logs, telemetry, backups, embeddings, and model processing in approved region. So do not use a region that is not approved by Azure policy or by the company policy. Retention policies define log. So under retention policies, you define log and how long the logs should be kept, define memory, define prompt, define data lifecycle, so information is not stored forever. So you can't store information forever, particularly customer information. For example, if I'm working in a company, when I resign from that company, my information should be deleted immediately. It must not be used against me. So information must not be kept forever. Determine the life cycle of the information and how long it should be retained and deleted from the system. All right, the next thing we have here after governance is cost and observability. Remember, observability is always very, very important in software application as well as in agentic AI application. It is more important in agentic AI system application than even traditional software. But though all of them still require monitor observability, and it is said that you cannot measure what you don't observe. And then observability metric are classified into three. We have the SLO, that's service level objective, SLI, service level indicator, and then error rate. So it's very, very important. We've been discussing this from beginning. We've discussed it extensively from the beginning of this domain 3 under monitoring and operation. So we want to look at it again: observability and cost governance. So the architecture terms that you should understand here is token usage. Okay, very, very important. Token usage enable you measure total cost of ownership. Okay, and you can determine the amount of cost that the LLM, the base model, which is the LLM, is generating, so that you can quickly track it down and minimize it and keep it within the range of what is used. Then budget alert, so you can set budget alert. So agent must never generate cost that they are not meant to generate. Set budget alert when budget is, when the agent is spending up to what you have set, then you should receive alert and go and check what is wrong in the system and what is making the system to generate the amount of cost it's generating. The cost management is very, very important. You can use cost management on Azure to set alerts, to set budget, and to monitor the cost of the agent. And then you can also collect a cost metric. Okay, then two costs. So monitor agent two costs, because if agent call tools, whenever agent call tools, they are using token, and whenever agent implement tools, they are using token. So if agent call tools inappropriately, then cost will also increase. So also monitor the way agent call tools, and then monitor another language here, another architecture term we have here is hallucination rate. So understand very well this architecture term very well as an observability and cost governance architecture terms that you should put in practice and include in your design. So let's look at them one after the other. Always make sure you log prompts, responses, errors, tool calls, failures, safety event, latency, token use, and cost metadata. Very important. Dashboards track success rate, failure rate, hallucination rate, average cost, token usage, escalation rate, and adoption. Okay, so we've discussed this before, so we should not be wasting time on this. We've said that you can use application insight, to collect metric and analyze and visualize there. You can use Power BI to visualize, to analyze your log. You can use a log analytic workspace in Azure Monitor with using KQL query to analyze in real time. Then we have cost governance. So cost governance monitors tokens, monitor token usage, API cost, model usage, storage, budget, and alert. So all this can be all these are metrics that you can collect under cost governance and use it to determine your total cost of ownership of the agentic AI system application. Then we have used the last point here says use Azure Monitor cost management on Azure or budget, alert, log analytic, and Power BI scorecard. Okay, as your tools here. And then application is, when you're talking of Azure Monitor, so application insight is also used for this agentic AI system monitoring and observability. Application insight should be part of these tools that you can use. All right, so we are done with this section on security, governance, and observability and cost optimization. So when we come back, we'll be looking at the last part of this domain 3 lesson. So, and if you are just joining us, please kindly like and subscribe so you can see more of our video. Thank you. See you in